Assalamualaikum. So I am Ahmad Ukasha and this is our project. So for my part, I will be explaining part A and part B of our project. So for my project is part A, we can see at the results and discussion, run the load flow to determine the maximum current at each feeder. So after I insert all the values that has been given out to us, we get these values. So the maximum current for each feeder at relay 1 until 13. This is the one. Next is run the short circuit analysis to determine fault current at all buses. So we do a short circuit at each of the bus. So we have about 5 buses. So at these 5 buses, each of them we will do short circuit one at a time. So as we can see, at bus 1 we do short circuit and we get the fault current at these 13 relays. Next is at bus 2 and bus C, right, and at bus 3 and at bus 4 and at bus 5. So finally is the max current through each bus during fault at every relay. So this is the values that we get. That's all from me, and I will pass it to Aiman to continue the project. Thank you.
Hi, my name is Muhammad Aiman Hanif and I will present about part C, which is select the transformation ratio of the CTs utilizing class 5 PCT and suitable accuracy limit current. So first of all, the accuracy of the current transformer must be maintained to a specific degree during the overcurrent grading procedure. This is achievable with the burden expressed in VA at the rated current and suitable load rating. The secondary CT's value has been chosen to 1 ampere because rated current for the transmission line is also 1 ampere. So this is formula for CT secondary. ALF or accuracy limit factor can be calculated by dividing the fault current by the primary CTs. The standard value of ALF is graded at 5, 10, 15 and 20 must be obeyed. ALC or accuracy limit current can be calculated from the product between ALF and rated CT secondary, which is 1 ampere. So this is formula for ALF and formula for ALC. And the table below shows all the information of relay and class for the CT connected with the relay. And from this class we get, so start we in the value in that. So for relay 1, we set the CT ratio is 151 and class for the CT is 5P5. And for relay 2, we set the CT class for 5P5 also. Relay 3 also class is 5P5, and same with relay 4, the CT class is 5P5. Next we go to relay 5. The relay is connected to bus 2 and the CT is 5P20 and the ratio is 401. And for relay 6, the CT connected at the class with 5P15 and the value for ratio is 901. Relay 7, the thing is 601 and class for the CT is 5P20. Same with the relay 8, in the value we get from the table 5P15, 901 for the ratio. For part 8, 5P15 and the ratio is 901. For relay 9, connected with the ratio is 701 and the class for the CT is 5P20. Next, at the bus 4, connected with relay 10, and the CP reset is 55, and the ratio is 150 and 1. And relay 11, CP connected is reset to 5 in 10 class, and the primary is and the primary ratio is 900, and secondary ratio is set at 1. And the last bus, which is bus 5, the relay connected is relay 12, and CP is 551, and class for the CP is 5 in 10. And the last relay is relay 13, the CP connected 5 in 10 and 100. So we must make sure all the CP connected is same with the CP ratio that we set in this table from the calculation of I fault divided by maximum fault current. Okay, that's all for me, and I will pass to the next member to present for next part. Thank you.
So now it's my turn, which is I'm Muhammad Faris bin Johari. So what the task have been given by our lecturer, that partly is to determine the value of the pickup setting and also the time dial setting for the all relays to make sure that protection system is coordinated. So this is the discriminate time that we have been fixed it, which is 0.4 second, and then next is TSM, which is 0.1 second for relay 10 until relay 13, and then plug setting 50%, the range is 50% until 200%, and then the increment is 35%. And then for the how we get the plug setting, the pickup setting, plug setting multiplier, and then RCOT and ROT, we firstly we get from the previous from the our groups members have been doing it, which is the full load current we got from the table. Full load current here, load current we get here, and then we just put it from relay 1 until relay 13, and we get the plug setting, and then we divide with the CT ratio that we have been fixed. This is CT ratio that we have been adjusted, we determined by our group. And then PSM also we calculate that IFC over RSI. IFC we just for current step by step from bus 1 until bus 5, and then for current, which is the for current for bus 1, bus 2, bus 3, bus 4, and bus 5 here. And then we get the maximum. We just from the row here, we just take it maximum values. From here for relay 1, we took the 0.2326, and then we just put it row by row. And then this is bus 2 and bus 3 because the value is same for the maximum for current. Then we supposed to get the value of PSM over RSI. RSI we already calculate, and then RCOT, this is the general formula that for RCOT, and then TSM for R10 and until R13 is fixed, which is 0.1 second. We calculate, and then we get next. This is the calculation for the all relays for plug safety, RSI, PSM, and also RCOT and also ROT. So if you look at here, R13 is 0.379. We just put its TSM on in the ETAP. For example, TSM for you just take the TSM for R8, and then if you want to put it in ETAP for the TSM, we just click here. You know, this is relay 1 for the relay. I just took the one of the example. Relay A here. Just go to the OCR and then here 0.194. 0.194 is the 0.194, right, for the TSM. Just put the TSM step by step on the relay 1. Next, for the calculation above, we can make it in the table, which is we need the value of ROT and TCM to put it in the ETAP simulation for the next part, which is RENAP part. Now, when the TSM, this calculation is very we get from the formula. When the TSM increases, and then ROT also increases. This is because TSM provide the release real operating time in value, and then also the TSM also setting that control how quickly that the relay clicks. Like for example, the higher values of the TSM also, it will longer delay. Why? If the value of TSM lower, so the TSM indicate the shorter wait delay. So this is the value ROT and TSM we get from the calculation. So that's all from me, and next proceed to the RENAP. Thank you.
To produce the time current coordination curve of the relays on the system, first we need to select all the relays on the system, which is from relay 1 to relay 13. So let me select it first. So when all of the relays are selected, then we can click on the Create Star View to generate the IDMT curve. So this is the generated IDMT curve, and let me display the grid. So this is the result. So as we can see, this is the IDMT curve for relay 1, and this is relay 2. Relay 3 is here, relay 4, relay 5, then relay 6 is here, then relay 7, and relay 8, then relay 9 is here, then relay 10 is here, relay 11, then relay 12 is here, relay 12, and then the last relay 13 is here. So all of the IDMT curve of relay are displayed here, and the y-axis represents the time, the relay operating time in seconds, while the x-axis represents the fault current in ampere. So from this relationship, we can observe that the relay operating time is inversely proportional to the fault current. So when the relay detects a higher fault current, so it should be operate at a faster time compared to when it detects a lower fault current. So that's it for the IDMT curve.
So next, we're moving on to the last part, which is part F, where we need to confirm the sequence of relay operation of the relay for 3-phase short circuit at each bus. So as you can see here, this is the maximum fault current that we achieved from the previous simulation, which is short circuit analysis. And here is the value of ROT from the manual calculation. In this part, we need to compare the ROT value from the manual calculation to confirm that our simulation is correct. So for the bus 2, so as you can see here, the maximum fault current for relay 1, 2, 3, and 4 we obtain from the fault at bus 2. So for the relay 1, we will obtain 3.47 seconds. It is quite similar to the manual calculation. For relay 2, 3.573, also quite similar. For relay 3, 3.07, which is also quite similar. And for relay 4, 3.174. Yeah, it's still the same. Next, we're moving on to the fault at bus 3. As you can see here, there are 5 relay. They obtain the maximum fault current at bus 3. So starting from relay 1, 3.47 as same before. Relay 2, 3.573, same. Relay 3 is 3.07, similar. Relay 4 is 3.174, still similar. And relay 5 is 1.834. Is quite high, but still in the range. So next, moving on to the bus 4. So for bus 4, we will looking at relay 6, 8, 10 and 11. So for relay 6, we will obtain 0.929, which is quite similar to the manual calculation where we obtain 0.9286. Next, relay 8, where 0.53, which is quite similar. Next, relay 10, 0.392, it is similar. And relay 11, 0.428, is similar to the manual calculation, as manual calculation is 0.4278. So next, for the last bus, which is bus 5. So we will looking at the relay at bus 5. So there will be relay 7, 9, 12 and 13. So 7, we will obtain 0.81. Quite similar. It is similar to the manual calculation. Relay 9, 0.408. It is quite similar. 12, 0.405, which is similar. And lastly, 13, 0.368, which is quite similar to the ROT for manual calculation, which is 0.3679. So we can conclude that our ROT value is correct for this calculation. Thank you.